this presentation, I will introduce you to a place in Tanzania that has defined much of what we know about human evolution. This place is called Oldupai Gorge. It is a world-renowned paleo-anthropological complex that captures the last 2 million years of human evolutionary history. It is here that for more than 100 years, researchers have uncovered stone artifacts that were discarded by human ancestors in an ancient lake basin occupied by diverse flora and fauna. With this preface, let us begin on our tour of the artifacts, fossils, sediments, and sites that have come to define Oldupai Gorge. Before diving into the topic of this presentation, it is necessary to consider from where the theory of human evolution holds its own origins. This brings us to the 19th century, more specifically to the writings of naturalist Charles Darwin, who in 1837 sketched his first evolutionary tree. More than 20 years after sketching what has become an iconic metaphor for the evolution of life on Earth, Darwin would publish a seminal work titled On the Origin of Species, which went a great way in discrediting the prevailing episteme of the day, which was guided by James Ussher's reading of the Old Testament, who assigned the age of Earth's godly creation at a meager 4004 BC. By building on the work of individuals like Gray, Huxley, Hutton, Leclerc, and Wallace, Charles Darwin, in his 1859 book, proposed the theory of evolution by way of natural selection and theorized that living species held extinct relatives that could be retraced to a common ancestor. What's even more spectacular is that Darwin developed this evolutionary theory a number of years before the infamous Neanderthal fossils from Germany, Belgium, and Gibraltar were recognized as different than that of our own species, Homo sapiens, and thus indexical of human evolution. In taking a 180-year leap from when Darwin first sketched an evolutionary tree with not even a single hominin fossil to tack on, we arrived to this, where as of 2017, we had a cast of 27 species and counting who are believed to be on the hominin lineage. In adding a geographic component to what Bernard Wood calls a quote-unquote species-rich interpretation of the fossil record, we see that the African continent is not only home to the earliest members of the hominin lineage based on first appearance datums, but is also home to the earliest representatives of the genus Homo, as shown in turquoise. Narrowing down our geographic scale from continents to regions, we may point to East Africa as the theoretical center of endemism for tool-making hominins by plotting the oldest fossil and archaeological sites across Africa, resulting in what Yves Coppens has dubbed the East Side Story. While it must be acknowledged that the fossil and archaeological records are incomplete, spatially biased, and imprecisely dated, there are several factors we can point to as to why East Africa represents an important source of information, not least of which is the East African Rift System, as shown by the cluster of fault lines on the right, together with a prolonged history of mountain building events and pulsing volcanism, which had the effect of creating natural basins that became the sinks of sediments, fossils, and stone tools of Plio-Pleistocene age. One of the richest and best known sites in all of Africa is Oldupai Gorge, which is unsurprisingly located in northern Tanzania along East Africa's Great Rift Valley. Oldupai Gorge itself is an ancient basin that formed as a result of volcanic uplift, which created a natural depression for an ecologically attractive water body to emerge, for sediments to accumulate, and for geological activity to continue unabated, best seen by major fault lines. In the background, you see 3 of the 4 major volcanoes that were the primary sources of sediment you see in the foreground. These 100 meters of sediment are subdivided into 4 primary units that are intercalated by a number of marker tuffs that were deposited from the volcanoes in the background. and these tuffs allow us to constrain the age of the archaeological and fossil-bearing layers. In terms of why this area is so special, there are two factors we can point to. First, the sedimentary environment was of low energy, which facilitated the preservation of stone tools and fossils. What's more, despite the sedimentation being of low energy, the rate at which sediments accumulated was rapid, and so this promoted the burial of archaeological and faunal material that cover huge slices of time. When peering across the Oldupai Gorge, we see extensive evidence of geomorphology at work. In fact, one of the leading causes that led to the creation of the Oldupai Gorge is a 400,000-year-old river system. This river system has since been recognized as a gift of nature by paleoanthropologists, since it has had the effect of exposing surface collections of artifacts and fossils which can serve as a proxy for a site's potential. Like these ones shown here from the site known as Iwas Oldupa, which has recently been shown to withhold Oldupai's earliest known Oldowan stone tools. As a direct result of geomorphological forcing, we are certainly not deprived from a paleoanthropological perspective, as there are 75 known sites across an area of approximately 200 square kilometers, spanning more than 2 million years of cultural and natural evolutionary history. I would also like to draw your attention to the prominent volcanic centers on the right-hand side, as some of these are the primary sources of volcanic ash that we can use to constrain the age of the archaeological and fossiliferous sites within the ancient lake basin. When we take a step back from the field setting and retrace the research conducted at these 75 paleoanthropological sites, what we see is an illustrious history of investigations spanning more than 100 years, over which a number of researchers have addressed pivotal questions in human evolution. These have ranged from the question of what technological precursor comes before the Acheulean, to establishing the chronometric age of the Oldowan, to refining the definition of the genus Homo, and more recently, to whether bone surface modifications and skeletal part profiles attest scavenging or hunting behavior by hominins. The totality of high-impact discoveries, together with what seems like an inexhaustible well of fossil and archaeological material, have positioned Oldupai Gorge as a premier reference site on a global scale, which we will now examine. During the first scientific investigation of Oldupai Gorge in 1913, Hans Reck discovered fossilized animal remains in early Pleistocene deposits together with a human skeleton. According to Louis Leakey, Reck firmly believed that the skeleton was the same age as the animal fossils. But over the course of scientific debate that played out in nature, Pete Boswell demonstrated that the matrix attached to the bones was different than the surrounding sediment, thereby implying that the individual must be of significantly younger age. The issue surrounding the age of the individual was apparently laid to rest when it was radiocarbon dated to almost 17,000 years before present, although it must be noted that doubts have since been raised about the actual researcher who conducted the dating. Regardless of the potential inaccuracy surrounding the age, recent studies have indicated that OH1 was a young adult male who was deliberately buried, and teeth wear suggests that this individual wore a dental adornment. But ultimately, what sparked interest for continued research at Oldupai Gorge were the faunal remains that Reck found, since they were clearly fossilized and therefore hinted at the possibility of future discoveries rivaling those that were known at the time from Europe and Asia. 72 years after two British geologists discovered what Clive Gamble and Robert Krasinski have called the stone that shattered the time barrier, Louis Leakey would do the same at Oldupai Gorge. As the story goes, within half an hour after arriving to the gorge in 1931, Louis Leakey went out to explore and found a number of Acheulean hand axes eroded from the sediment at the site of CK or Imugurri. The next day, Leakey returned to the same area and established from which sedimentary unit the handaxes eroded from. He then opened an excavation pit only to confirm his suspicions by uncovering what we have here as the first in situ Acheulean handaxe from Oldupai Gorge. Overall, we may point to this discovery as one of importance in the history of paleoanthropology, but another 28 years had to pass before Louis Leakey got what he was really looking for at Oldupai Gorge. As alluded to, the most important discovery came on July 17, 1959, when Mary Leakey discovered the skull of what is now known as Paranthropus boisei at FLK Zinj. Mary and Louis Leakey would then go on to open a massive excavation in the immediate vicinity, which led to the discovery of over 2,400 Oldowan stone tools and approximately 60,000 faunal specimens, some of which were shown to bear traces of butchery, all of this along an ancient lakeshore. Overall, the importance of this discovery cannot be understated, since it had the effect of shifting the world's attention directly to East Africa in the search for human origins, and led to the bone rush over the ensuing decades that played out across Kenya and Ethiopia. For the Leakeys, finding OH5 and what was then interpreted as a quote-unquote hominin living floor allowed them to secure funding to continue uncovering tantalizing glimpses into the lifeways of Pleistocene hominins for years to come. But the Leakeys were not alone in their ancestral passions, as they brought on a number of researchers throughout their investigations to strengthen their interpretation of fossils and stone artifacts. One such example was teaming up with Garnis Curtis and Jack Everton, who collected samples of volcanic ash to determine the minimum age for the underlying sediments at FLK Zinj. After 4 years of arduous laboratory research, their efforts proved worthwhile as they published their pioneering Potassium-Argon dates for FLK Zinj, placing the artifacts and fossils at no less than 1.75 million years ago, which was more than 3 times that of previous estimates. The following year, and only a few hundred meters from FLK Zinj, the Leakeys made yet another momentous discovery. In a 1964 article in Nature, Louis Leakey, Philip Tobias, and John Napier argued that these new fossils shown on the left displayed evidence for an upright posture, a bipedal gait, an ability to manufacture tools, as well as smaller teeth and a slightly larger brain than Australopithecines. As such, the new species was named Homo habilis, meaning handyman, because they suspected that it was this larger-brained, more human-like hominin who made the stone tools at FLK Zinj, not Paranthropus boisei. Over the years, this evolutionary model has been challenged, since the designation of stem species in the genus Homo continues to prompt scientific debate. What's more, a number of species have been stratigraphically associated with Oldowan assemblages, and more broadly, the emergence of the Oldowan some 2.6 million years ago can no longer be explicitly linked to a synchronous reduction in teeth size and an expansion in brain size among hominins at the Plio-Pleistocene transition. Despite these outstanding questions, comparing the skulls of Paranthropus boisei and Homo habilis offers a striking visual. On the left, we have Paranthropus boisei, and right away we see a powerful jaw evidenced by large zygomatic arches, massive molars, prominent sagittal crest, and a relatively small brain case. On the right, we have OH24 assigned to Homo habilis, which was painstakingly reconstructed and was distorted during fossilization. But still, we can see clear differences with OH5, like a forward projecting face, a rounder and bigger brain case, an emerging forehead, and a smaller face. Despite these two species showing morphological differences, the possibility remains that either one or both were tool users and tool makers. Moving from the hominin fossils to the geology, perhaps one of the most impactful collaborations with the Leakeys was the work of Richard Hay, who would, in his 1976 monograph, provide an authoritative framework for the geological evolution of the ancient basin. One of Hayes' many contributions was correlating the sediments across space, which proved difficult since there was much lateral variation in the stratigraphic sequencing due to syn and post-depositional faulting. From left to right, we have a series of photographs of the same stratigraphic section, which provides a glimpse into Hayes' process from the field to the publishing press. Invoking Hayes' geological research, one important consideration in the interpretation of fossils and stone artifacts is their paleogeographic context. Over most of the depositional history at Oldupai Gorge, the area proved ecologically attractive for hominins and animals alike, as there was once a perennial lake during Bed 1 times. During the deposition of Bed 2, the Paleolake fluctuated to a smaller size, and the area was affected by a number of faulting events, which likely impacted the basin's hydrological system. Over the course of Bed 3, the Paleolake eventually gave way to braided streams that drained into a playa lake to the north. Across the entirety of these three sedimentary units, spanning approximately 1 million years, the climate became progressively arid, and about halfway through the deposition of Bed 2 is when we see the first evidence of Acheulean lithic technology at Oldupai Gorge. Oldupai Gorge is not only known for its fossils, artifacts, and volcanic ash, but also for a globally recognized geophysical phenomenon. Paleomagnetic analysis is an analytical technique that can detect variations of the magnetization of rocks according to the position of magnetic north. Over geological time, there were reversals in the Earth's magnetic pole. One of these reversals is known as the Olduvai Event, as it was first recognized in basalt from Oldupai Gorge and is dated between approximately 1.94 to 1.78 million years ago. Importantly for paleoanthropologists, we can use this technique to constrain the minimum and maximum age of fossils and stone artifacts. In fact, this technique was employed by Blumenschein and colleagues to securely establish the age of OH65, identified as Homo habilis, and disprove the previous interpretation that the area's sedimentary deposits post-dated Bed 1 times. Moving from the geology to the cultural material, the African earlier Stone Age encompasses what are known as the Lomekwian, Oldowan, and Acheulean industries listed here with their first appearance datums on a continental scale. At Oldupai Gorge, we have the Oldowan and Acheulean industries represented, and this is in large part thanks to Mary Leakey's pioneering excavations, which culminated in the publication of Olduvai Volume 3, in which she described in incredible detail a succession of Oldowan and Acheulean assemblages from a number of archaeological sites. Now, from an artifactual perspective, what are we referring to? Well, Oldowan assemblages are broadly characterized by hammerstones, cores, flakes, and debris, while Acheulean assemblages also include these artifact types, but are primarily identified based on the presence of handaxes, cleavers, and picks, which can be thought of as index fossils. Here we have what Mary Leakey identified as the earliest Oldowan and Acheulean assemblages at Oldupai Gorge, coming from the sites of DK and EFHR respectively. On the left, we recognize a number of choppers and discoids, and on the right we have a cleaver and two bifaces, representative of the Acheulean. Both of these sites are located in the eastern sector of the ancient lake basin, as you can see here with FLK Zinj displayed for reference. This is important to note because for much of the history of investigations at Oldupai Gorge, researchers have primarily focused on the eastern basin since it has proven rich in fossils and artifacts. But as OH65 has taught us, which I discussed in relation to paleomagnetic analysis, the western basin has much to offer. Banking on the Western Paleo Basin's potential, our team recently confirmed it by publishing an interdisciplinary study on a new site called Iwas Oldupa, meaning on the way to the gorge in the local Ma language. You can see the location of the site on the inset map relative to those discussed previously, including the OH65 find spot, which is only about 350 meters to the west. Among other things, we were able to show that the earliest stone tools from Iwas Oldupa are dated to approximately 2 million years ago, making it the earliest known archaeological site in the entire gorge. Shown here is a selection of Oldowan artifacts from the newly excavated site of Iwas Oldupa. You will notice a few cores, including a couple of choppers, a spheroid, and several flakes. All of these pieces were manufactured from quartzite and ignimbrite that would have been available in nearby riverbeds. I would also like to point out artifacts A, B, and C, as these were among the excavated finds from our lowermost trench, annotated with a black star on the graph on the right. You can see that our trench 7 overlies the so-called Nabi ignimbrite that has been securely dated to 2.03 million years ago. If we move up this graph into what is known as bed 1, we can identify a succession of different depositional environments and plant communities intercalated by several volcanic tuffs. When we plot the DK Oldowan assemblage from the eastern basin onto this graph, we know it underlies the volcanic ash known as tuff 1B, while at Iwas Oldupa, there is approximately 20 meters of sediment between the site's earliest hominin occupation and tuff 1B, which translates to an earlier appearance of the Oldowan at Oldupai by approximately 180,000 years. I would like to now show you a digital outcrop model of Iwas Oldupa. Looking southwest into the gorge, you can see the green-colored Nabi ignimbrite dated to about 2 million years ago along the riverbed. The site's earliest occupation occurred atop this unit in what was a post-eruptive landscape near a meandering river flowing northwest. Now zooming into the outcrop, you can see our team excavating a series of trenches, and along that cliff face you can pick up a number of resistant horizontal bands, which are layers of volcanic ash that were deposited from the volcanoes to the southeast. Seeing this model not only gives you a good sense of the landscape, but also just how lucky we are as paleoanthropologists, since we are given access through recent geomorphological processes into an important window of our evolutionary history. As we have seen, Oldupai Gorge is not only known for its Oldowan sites, but also for its Acheulean record, as you'll recall with Mary Leakey's 1931 discovery of handaxes at the bed 4 site of CK or Imugurri. But today, the Acheulean record at Oldupai is known to stretch as far back as 1.7 million years ago, represented by the site known as FLK West. In 2015, a research group opened up a trench less than 60 meters from FLK Zinj. Here, they identified 6 archaeological levels associated with an ancient river channel, which was tightly bracketed between 1.69 and 1.66 million years ago. And what they recovered was pretty spectacular, as it included bushered faunal remains and lithics, including this highly symmetrical 30 centimeter long handaxe manufactured from olivine basalt. While the Oldowan record at Oldupai Gorge postdates the stone tool industry's first appearance datum by approximately 600,000 years, this is not the case with the Acheulean, as FLK West is the 3rd oldest known site on the entire African continent, postdating the sites of Kokisele and Konso Gardula. On a broader scale, the 1.6 to 1.5 million year old sites of Swartkrans, Sterkfontein, and Ubudea, stretching from South Africa to Israel, could support a rapid dispersal model of Acheulean technology from somewhere in East Africa. Regardless of whether this proposition is correct, one thing that remains certain is that the archaeological record of Oldupai Gorge will continue to serve as a key reference site on a continental and global scale. When shifting from stone tools to animal fossils, The foregoing point about Oldupai Gorge serving as a key reference site holds just as well. This is perhaps best put by a fantastic quote from an article written by Jackson and Zhao, in which it is said, quote, more than 200 vertebrate taxa, including approximately 25 holotype species, have been documented at Oldupai Gorge. You will recall that we already reviewed 2 of these holotypes with Paranthropus boisei and Homo habilis, but still the list goes on when going beyond hominin species. One reason why Oldupai's Pleistocene fauna is important is that it is chronologically constrained thanks to layers upon layers of datable volcanic ash. In turn, this has allowed researchers working elsewhere to correlate the ages of fossiliferous sites according to Oldupai's sedimentary deposits by a technique known as biochronology. This information can also be used to identify the biogeography of Pleistocene vertebrates, faunal community turnovers, and for taxon-based paleo-environmental reconstructions. What's more, a lot of what is known about the dietary behavior of early Pleistocene hominins is based on Oldupai's anthropogenic faunal accumulations that have been interpreted as falling on a spectrum between scavenging and hunting. But of course, hominins were not alone in their pursuit of meat and marrow, shown here with some of the carnivores recorded from Oldupai Gorge, including the bat-eared fox on the upper right being an extinct holotype species that was named after Hans Reck. Moving down the Pleistocene food web, we can see that the Oldupai Basin was an ecologically attractive niche for a number of species, ranging from water-dependent taxa like hippopotami and fish, to specialized grazers like cercopithecines and equids, to massive bovids adapted to open environments. I would also like to point out that 7 of the 12 species listed on this slide are holotypes from Oldupai, which really accentuates the importance of its faunal record. As I alluded to, archaeological sites across Oldupai Gorge have yielded faunal accumulations with anthropogenic traces of butchery and particular skeletal part profiles. Some of these faunal assemblages have been interpreted as evidence for everything from passive and confrontational scavenging to full-on hunting by hominins. While some sites have occasioned debate on whether hominins had primary or secondary access to meat and marrow, when and where stone tools and cut-marked bones are found alongside one another, it is reasonable to theorize that they are functionally related. With this being said, not all early Pleistocene hominins were the apex predators that we might imagine, particularly when we consider the body size of species predating the appearance of the more human-like Homo erectus, shown on the slide here, transporting parts of an elephant carcass away from a kill site. Not only was it that some hominins had small body sizes, but the fact that they foraged in and around wetlands meant that they faced predation risk from large carnivores. Perhaps some of the clearest evidence for this from Oldupai Gorge is the OH8 foot classified as Homo habilis. The specimen in question was discovered not far from the type site of a new crocodile species, and it famously bears a number of crocodile teeth marks along its talus. Despite facing predation risks, hominins returned to a number of lakeshore sites to access meat and probably plant foods. Perhaps one of the most tantalizing sites with regards to this latter possibility is FLK North. According to recent studies, the archaeological site was situated atop a dry, densely wooded promontory that featured palm trees surrounded by a wetland. Where it gets interesting is that the site has been interpreted as a palimpsest of unrelated animal and hominin accumulations. The reason being is that there are barely any cut-marked bones, and the majority of stone tools present have been interpreted as evidence for percussion activities. While this site may very well represent Oldowan tools used for plant processing, the lesson learned is that the archaeological record is biased towards bone, and that paleo-environmental reconstructions can help to identify the factors that attracted hominins to particular sites on the paleo landscape. Recalling Charles Darwin's sketch of what has morphed into an iconic metaphor for the evolution of life, it can be said that facts were once in short supply when thinking about human evolution. I hope that with this presentation, I've done justice to the illustrious history of research at Oldupai Gorge that has illuminated many of the now established facts concerning the natural and cultural history of our African human origins. To conclude, I want to express my sincere gratitude to the following institutions, agencies, the Maasai community of Oldupai Gorge, and all individuals who made this presentation possible. And last but not least, I want to thank you for your attention, and I wish you a wonderful experience at what should be an exciting 3-day conference.